Good evening, everybody.
Good evening.
Yeah. Good evening, Josh. Welcome to TWed. Tonight, we're honored to have Myra Gordon give us this I characterized it earlier in the day as a sort of a software engineering meets semantic web application construction or system design. It should be really interesting. Hopefully you have some controversy. Have some provocative comments, start some fights. Okay, just a bit of logistics. We are recording this. This will be available through our TWed YouTube. And actually, I make these, the Rinser Idea has a new website, and I've been making some of these videos available through the new Rinser Idea website. They have a nice layout. So feel free to ask questions. Myra is mostly left time for questions, right?
Yes. At the end.
So maybe not for me. Without further ado, take it away. I'll just go to switch over to.
Okay.
Do I have to give you the ball?
No, I think you're all
right.
Okay.
You have it.
We don't have it there.
Oh, and why don't you enable your mic?
So I'll go ahead and get started. Where do you want me to stand?
You're not going to be on video.
Oh, okay. That's right.
I mean, that's okay.
Okay. So I'm going to talk about a clean architecture for semantic. Here's a brief outline of the talk. First, I'm going to talk about what is the clean architecture. I don't think I need to explain what semantic web applications are. Just generally, they're using semantic web technologies, RDF, Sparkle, and so on. And then why do we need such a thing? And finally, how it's designed and how to implement it. I'll take questions at the end. There's a fair bit of material to cover. So, what is it that I'm going to be talking about? It's a way to engineer semantic web applications that essentially consists of a software architecture, which is kind of a high-level design that's not specific to individual technologies, and then talking about the specific technologies that's I've been using and some students have been using. So the types of applications we're talking about are, for example, navigating a food knowledge graph that's Solo and a few others using the HEALS project, as well as visualizing wireless spectrum access policies in the DSA project. I've been working on a couple of other things, but those are the things that are priorities at the moment. So why are we doing this? In order, help students learn modern software engineering. I think that's a big function of the lab. And modern software engineering, I'm loosely interpreting as design patterns and technologies that are widespread in the industry. The second point is to deliver bespoke web applications for responsive research projects, including DSA, including HEALS, machine common sense, not right now, but probably later, and so on. So that's also a large portion of what we do at the lab. I would argue that the two should be serving one, but we obviously need to do them both. And finally, the research side of things. So these are my kind of personal priorities. I know that things shift around. I tend to do the research bits last, and focus more on the software piece, helping students. So the how. Just a little bit of a review of the solid concepts. So these were pretty well documented in a book by Bob Martin in the early 2010s called Clean Code, which is a little bit of a Bible of modern software engineering. The solid principles are, he codified them from long-standing principles. So a class should have a single responsibility. We're talking about object-oriented programming here. Software entities should be open for extension, but closed for modification. So you shouldn't be able to mutate the internal state of objects. I'm not going to go deep into that one. Liskov substitutability, that's a long-standing principle of if B extends A, then B should be able to act like an A, more or less. And interface segregation, that's really important for this talk in particular. To break apart the client-specific interfaces, and then in Java you can have multiple interfaces, scale it to Python as well, rather than having one big interface. And most important for this talk is dependency inversion. So you should depend on interfaces and not on implementations.
Ryan, can you see if you can
move
that
absolutely.
little box?
Yeah, we'll do that here. I actually don't see it on my. Okay, I just don't see it on my screen. That's okay. All right. Great. Okay. So the solid principles. So Bob Martin later published a book called Clean Architecture, which builds on clean code, about much higher level concerns. There is a clean architecture, which the book is about. He was trying to synthesize a number of software architectural ideas that were floating around at that time. The clean architecture, I'm actually not going to focus on this one. This is the synthesized version of it. But the idea is essentially that the outer circles are mechanisms, and as you get further into the centric circles, you're talking about policies. So things get gradually higher level as you go in. There are dependencies from the outside in, but not vice versa. And that's where the dependency inversion principle comes in. Everything in the center depends on interfaces at the same level as the center. Those interfaces can be implemented by things at outer levels, but the things in the middle don't know about those implementations. So prior to this, one of the designs that was synthesized in the clean architecture was called the onion architecture. A lot of people know this term rather than the clean architecture one, and I find it a little bit more intuitive in terms of the nomenclature. So on the outer ring, you have user interfaces, test servant structure. This is as specific as it gets. So you're not going to avoid writing very application-specific code at that level. GUIs by their nature are very application-specific. Then on the next rung in, you have application services. These are things like REST APIs and so on. I'll talk about this in a moment, which are specific to an application, but not so specific as the user interfaces. Then domain services, which are higher level still. And then the sort of GUI role core there is the domain models, where you end up with the what he calls entities, business rules, basically, in the middle. So just working my way out, starting from domain models. What are we really talking about there? Models can mean a lot of things, like model view controller. The classic model view controller is actually an application service. So that's something that's talking with external interfaces. It's typically not at a high enough level to be called a domain model. The domain model, this terminology typically comes from domain-driven design. This idea that we have classes that directly reflect things that are in the domain. So for example, DSA has a policy, frequency range, and device class, requesters, dates, and so on. These are things that the domain experts talk about. That's kind of the domain-driven design aspect of it. In HEALS, we have guidelines, conditions, directives, and so on, to include the American Diabetes Association guidelines. And a geo demo that we've worked up, also sort of connected to DSA, you have feature and geometry. So these are very, very high-level concepts that don't necessarily correspond exactly to things in a user interface. So what does this actually look like in practice? DSA is probably the most evolved version of this that I have at the moment. There is a project under the TWed's World GitHub called DSA Models, which has these guys. They're a bunch of high-level classes which encode, essentially capture the wireless spectrum access policies. So policy has a date range, some sort of textual definition, enum effect, and so on and so forth. These end up being constraints in OWL, but of course this is a much more succinct version of capturing those semantics. And you can't run a reasoner on this. but the idea is that we're going to work with it programmatically and then translate as needed into lower level things. No, that's a superclass. Yeah, it's just a superclass in the domain model hierarchy. Okay. So, what are domain services? So typically, what we're talking about is the relatively low or relatively simple applications that we're working with here. These are microservices that are going to do probably CRUD, some sort of store thing. The main point is that you are working on an interface level and not at implementation. So there's a high-level store which has CRUD type methods, but it doesn't necessarily prescribe anything about where you're getting the data. So it could be from a database, could be from a file. That's this whole notion of the dependency inversion plus the interfaces and adapters. So down here you have, this is the interfaces and adapters one. So down here you have external interfaces, which is the database, and up here you have the store, which is declaring the high-level CRUD for that external thing. So the external interface is the implementation, the database, the triple store or whatever is the implementation of this very high-level store. And that's essentially what it looks like. So this is Scala Sparkle or Scala trait, just equivalent to a Java interface essentially, and then it's got a couple of methods to get policies by ID or a list of them. Okay. So application services are the next level up. So you notice that these high-level domain services, they don't have anything about serialization, right? They're just talking in terms of domain models. Give me this domain model. I'm not talking about HTTP or anything. So you need another layer outside of that, which is application services. This is the thing that's going to translate a get HTTP request, the REST interface, into a get policies, and then it's going to serialize. It's going to look at the accept header and content types and all of these things. It's essentially a rounded version of that store interface. Pretty quickly. A little bit. What does this actually look like in practice? So one of the I've been preferring GraphQL interfaces to REST interfaces for a couple of different reasons. We actually have graph models in a lot of our applications. You can see the graph in the policy case class, of course. The policies themselves form a big graph. So it's kind of natural to lay a GraphQL API on top of that. So yeah, the other natural thing about it is that there are nice tools to take those domain models, which are a graph, and translate them to a GraphQL API, which is typed. Required. I'll explain how sort of end-to-end pipeline. A little further along. And then finally, on this outermost rung, you have user interfaces. So this is things like you could say like Perl as a user interface. Usually, it's going to be the browser, client library, desktop application. So that outermost layer, and then infrastructure. That was the other part of the outermost rung. Databases and file systems. You could know other things here as well. But the basic idea is that these are as concrete as we're not abstracting out anymore. Okay. So implementation. Assuming you have this really high level design, right? Like, I mean, this is not prescriptive. You don't have to use GraphQL here. It does happen to use GraphQL, but the idea is, okay, we've taken this onion architecture and we're going to sort of substitute some semantic web type things in there. So RDF is serializations, triple store is the database, and so on. But the rest kind of stays the same as you would if you weren't using this. So I've implemented these interfaces using relational database. So going to the implementation. First of all, I think.
Can I ask
Yeah.
a quick question? Back to the graph type.
Yeah. You like that?
Well, yeah. Well, it seems very similar to, I believe it's Haskell. Types from.
Sure, data types.
Yeah.
It's actually fairly simple. It's much simpler than that.
Yeah. Okay.
It's got objects which are sort of.
But it's the sense that things that have this match.
Is it structural? Yes, it's structural because it lays on top of JSON. So it's sort of in some ways got the underlying JSON data model, but with types later. So first of all, I really like all the semantic web technologies. So that's the whole kind of point of putting these into this infrastructure. I thought that I could kind of take the best of all worlds, take some of these kind of GraphQL and TypeScript and so on. So I want to incorporate those. I also like all of these things: microservices, GraphQL, typing and dynamic typing. It's all one big. Yeah. Yeah. So
if you say they're great, are they still great?
Yeah. Yeah. Right. Actually asked Owen to work on a lot of these things recently, and like he went way deep into functional programming in Scala, which is its own special animal and didn't emerge for like 2 months. So that's why he wasn't at the DSA meetings. He was dealing in SIMA groups and combine operators and things. So the thinking here is that all these technologies are good for certain things and quite poor for others. I won't be provocative and say which I think is which, but tool for the job. So there's not one single job building a modern application. It's very, very many jobs. So it's a combination of databases, a lot of applications in multiple databases, multiple APIs, so REST plus GraphQL, multiple services, multiple user interfaces, and so on. And I want to avoid reinventing the wheel. So the idea is to try to get the most, given that the scope is, somewhat fixed, try to get the most quality out of it. This is actually implemented. Starting from the inner circle and going out again, the domain models. The one that I showed before is a Scala case class. Scala case class, as you know, Scala translates to JVM. So they are essentially Java classes, but with a bunch of fun magic added on top and generated code. So number one, they're immutable. I love immutable data structures. I use them in Java and Python as well. Of course, compatible with Java. It generates all these things you would like in a domain model, like equals, hash codes, dot copy is a copy on write method. And as I mentioned earlier, it integrates well with other tools. So you can expose these things really easily as GraphQL types. This big animal here is actually copied out of the rendered schema. So GraphQL, you can ask a server for its schema, sort of like Swagger or OpenAPI. But that schema doesn't exist anywhere in the code. It's actually derived automatically from the case class that I showed earlier. So I really like that. I don't like having to repeat myself. So if I can put the definition of a type somewhere and then have it essentially go everywhere else through code generation of one kind or another, whether it's reflection or using scripts or whatever, then I do that. So domain services, as I indicated earlier, implementing these in Scala as well. It's just a basic Scala interface that is then passed around with dependency injection. So, I assume that's a pretty familiar idea. Application services, been using the Play framework with Scala. I know Enrique has used this a fair bit in Java. I was resistant to it at first. I've come to appreciate it in large part because of how easy it makes it to implement GraphQL. It's very, very easy with this Sacria. This is actually a manually defined GraphQL type. So if you don't have the case class, for whatever reason, you have to do all of the business right there. which needless to say is not quite as fun as the case class. There's a really good GraphQL server library for Python called Graphene, which I like quite a bit as well. It has a similar syntax, just not quite ugly. Same basic idea as you're building up the schema programmatically. On the user interface side, I like TypeScript quite a bit. React.js. There's a library to act as a GraphQL client. GraphQL is basically just a JSON interface that has a single endpoint. So it's not like REST where the URL is expressing some notion of what you're querying. The querying is a JSON data structure. The query is a JSON data structure against the schema, saying what you want from that schema, and then the response is also a JSON graph version of that. The great thing about this using TypeScript is you can take that schema that I showed previously, which itself is generated from the Scala, and generate TypeScript types. So you have end-to-end typing at the service level, which really helps catching errors. So I've implemented systems in straight JavaScript where you have some sort of schema or data or whatever, and it becomes really difficult to change the schema without breaking, without even knowing where you broke the client. And Webpack and Cypress and testing standard tools. You can substitute other frameworks, of course. You know, there's Vue and there's other GraphQL clients and so on. This just happens to be the most mature version of the stack I have experience with. So this is an application that our student Joshua Wu is working on. Thank you, Joshua. Policy visualization, so requesting the GraphQL, the policies from the GraphQL, that's domain service that gets the policies, going through the GraphQL interface, and then rendering them in React, Material, TypeScript, and the Apollo client. Working on various visualizations of these policies. Don't read too closely. Yeah.
You don't mean Gordon.
Yeah. Putting on your Alice spectacles there. So finally, the last bit of the puzzle is like, where is the talking about the user interfaces on the outer rung? Well, obviously the data has to come from somewhere as well. So that's an internal project that I've been working on called the Telos World Knowledge Store, TWix. It is a provenance-aware RDF store. The basic idea is that you're not allowed to put things into the store except with provenance information of some kind. So that comes in the form of nano publications, create, read, update, and delete, and then some mechanisms for querying assertions only. Heather wants to give another presentation on this, so I will not go too deep in there, but this was originally designed to support DSA and other projects. The interesting bit is, you know, at a sort of like pedantic level, it acts like a triple store. You can query the assertions only. The interesting question is, how do you get the data into those domain models? So if you are, if you've got that high-level policy domain model, well, and a bunch of OWL RDF, how does that work? It's not easy. I ended up implementing a lot of this to translate RDF to those domain models, which is, as it turns out, pretty difficult, but pretty useful once you can do it. So Enrique is using this in the DSA code as well. Those domain models are much easier to manipulate than the OWL. So we now have sort of pipelines of convert. The OWL needs to be the final form because it's, you know, the sort of ground truth form because it's the thing we reason on, but converts from the RDF to those domain models and then convert from the domain models to something else. So like a meta language or another rule language. That's something that Enrique and his student Sharon are working on. So there's a little bit of machinery to implement that in Scala. Scala has a nice facility called type classes, which are essentially designed, are a perfect fit for this and are often used for serial. So rather than attaching the serialization to the domain class, you have these sort of like ambient deserializers essentially that will
Schema R's or
Yeah, that's Owen and I started.
oh, I get it.
Yeah, Owen and I started implementing this specifically for DSA, and then we saw some common patterns for kind of libraries and libraries. The DSL that we talked about last week is essentially just translating that DSL to the domain model, case class, and then translating the case class out of the kind of center. So
HP Labs people, these guys working on a product sitting next to these guys working on Jenna.
So in summary, you can implement this architecture that I was talking about earlier, the onion architecture, with many different technologies. That's part of the point of it, is so that if you read the original blog post, the idea was to make systems more robust to change over time by isolating the business logic from the implementation. The business logic only talks in terms of interfaces, high-level abstractions like domain models, which are unlikely to change very quickly over time, or at least change in a very controlled way, whereas technologies, databases, and so on tend to change quickly or in uncontrolled ways. So when I sort of isolate my interface to those things and have some nice contracts between the high-level interfaces and the low-level implementations. So low-level implementations, we can use all of our beloved semantic web technologies as those things, serializations, databases. Questions? Thank you. Yeah. To the serializations or to the domain models themselves? Yeah, I mean, then you've got a sort of standard.
Yeah, we changed something.
Yeah. You need to capture all the semantics of everything. So the usual way is for them to become the union of everything.
Right.
Either that or you have strong versions where you like this is the V1 domain model and the V2 domain model. It's sort of standard versioning, API versioning. Yeah, I mean the domain model is an internal thing, right? Serialization, how you version the serialization, and so on is a different question. Your domain model is useful for your programs. You can kind of handle changes in serialization outside of it. That's an interesting question, is whether the domain model is the ground truth or whether the RDF is the ground truth. It depends on what you agreed on with the outside world, right? In DSA, for example, we're using RDF just for reasoning, right? So there's really could you serialize a domain model in JSON and have that be the standard formats, or something that was maybe a little easier? Because the premise is that the domain model captures its semantics. But we can capture the semantics in a way that's a little less fragile than the RDF. So that would probably be my preference. To have some sort of like migratable system, right? Like you have in relational databases.
You used the analogy earlier.
Typically, the business logic works on domain models. Yeah, the domain models are passive. They're typically data only. They're not like models in model view controller or object relational mapping, where they're just an abstraction of what's in the database. They're higher level than that. I want to break that. Yes. Yeah. 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 Case class is just a Java class basically with generates a bunch of helpful things like an equals method. In So Sana is just a library for doing this deserialization. Yeah, definitely, yeah. You guys or Sana? Oh, okay. So, yeah. So no, they're two separate projects. I should have broken them out in separate slides. Twix is basically just a quad store more or less with a defined API. So Sana is just a library for manipulating RDF. Two separate things. Does it have reason or support? Yeah. Directly on the store. We don't reason currently directly on the store. Well, I have experimental code to reason directly on the store. We don't do that currently. Just because I like client server if I can get away with it. Yes. Yeah. So the idea is to eventually try to move things close to the store, sort of stored procedure-ish. So that's what I have some experimental.
I like procedure. I like that word.
So, I mean, you talked about RDF over time. So the URI is the same URI. I changed the definition. It's always the same. So here, I'm curious what sort of evolution RDF store.
Can you
Why would you?
So step back. What do we mean by RDF?
I've just observed that just in our projects that our serializations seem to be changing. It's not inherently RDF. I just think it's probably a byproduct of how we're using it. We're using it as a serialization for some higher level semantics. We're not using it as a ground truth store. That's right.
What you're saying is you're going directly out of what we should be going through interfaces.
Yeah, we're doing what the application needs, not thinking about it in terms of a long-term data maintenance. Those are two separate things, right? I mean, just like in Heal or in DSA, we just change the RDF based on what the reason kind of diametrically what you would do if you had a relational database that you needed to evolve the schema over. I think RDF is also fragile.
Well, so let's let this is interesting.
We prefer
about the clean architecture.
They're effectively the same thing. So that was, I tried to preface that, but probably didn't really express it very well. The clean architecture came after, was a synthesis of several architectures, including the so people generally talk about the clean architecture. That's kind of, Bob Martin is a really influential guy. So that's and he also wrote about these things. But the onion architecture is simpler.
one other thing though. So with main models and specific assumes that the clients are. You don't necessarily in cases where you might. I'm thinking like in a lot of software projects are like Twitter or Facebook, where basically maybe there's an API, but the API store and all that.
Yeah.
But it's an enterprise system. It's ended up once or maybe a few times for testing. It is what it is, and that's all there is.
Yeah.
As opposed to something like where it's
Yeah.
used for many different purposes. And
more of a tool than an application.
Yeah. I'm curious about this approach for.
Yeah. This is not bad. So this implies a level of commitment to application specific things that is sort of on the other end of the spectrum of Twix is clearly in the tool universe, right? It's not prescriptive, whereas this whole approach is highly prescriptive. the idea is typically the more you prescribe, the more mileage you get out. It makes the GUI easy to do it all, but this automatic translation of things. So this is, yeah, I should have sort of prefaced it saying this is for when we know pretty much what the requirements, as we do in DSA, for example, as we know with like the yield guidelines. That's the background.
So, I'm trying to think of the right way to answer this question. So, when you're in a research environment, part of the DSA's been going on, and initially it was very research. We didn't know what we were doing.
Yeah.
The nature of research is not given a set of requirements. And then as it evolves, the phases you develop. I think if I was to map this life cycle, I think translates the basis for help.
Yeah, I think it's also worth pointing out that it's prescriptive in terms of what the user can do, developer. Because the developer can figure out what domain model they want and what they think best fits the system. It leaves us space. And I think what Jim is referring to is that locking down what they do.
Basically, it's not really intended to be. It's not intended to be a horizontal application, but or if it is, it's there.
So I guess where I'm trying to go is, how do you practice? How do you bootstrap this without constraint? That's really going from where we're here to up here.
Yeah.
When you start, as we did, with a clean slate, where it's like figure this out how this is going. You can't start. I'm asserting that you're loose. There are a lot of things. Because there's going to be a lot of applications for.
That implies that like startups who are doing that who approach software are not
I don't
as quickly
care.
as we
So
do.
I would contend, having done startups, it's a totally different thing. I'm not talking about that. I'm talking when you're doing research. If you're doing research, you can't start with the solution. You don't know what the solution is.
Start with a solution.
You're not necessarily starting with. Yeah, you're starting with an assertion that the solution might be in this direction. You don't know. That's right.
No, I get it.
You know, when we didn't know, and that's the great thing about it is we did it in a sufficient way that we had the agility.
We're talking about code here. We're not talking about.
I know, but how do you? I guess what I'm saying is, how do you make sure that your engineering approach doesn't force your hand, strain you from your research perspective, gives you tools that you need to do your research with openness, but doesn't constrain you.
I don't see that would have happened with DSA with this.
I don't know. In some early days, we reserved our implementation. I'm looking at Jim in particular because there was some early modeling we did of policies where we acted quickly how we resolved, how we evaluated. It would have been wrong.
Evaluate policies.
Yeah, we're evaluating policies.
But
we had some
notion-
early models.
Even representing.
Yeah, even represented, we trained ourselves. Jim restrained us, really. You know, no, he sort of imposed patience. Worked out. Okay, but no, my point is, we were operating at a high level, and we trained ourselves going at a lower level.
What does that mean?
Implementation. What?
What does that mean? Operating at a high level.
So we didn't have a computer. Kind of before, we had some policies written down. That's what we did.
It's more than that.
Well,
Yeah, we had graph representation policies,
Well,
but
yeah.
with no specific implementation or evaluation in mind.
well, okay, yeah. So you're thinking later on.
A little bit later. And that was really important because the next step, we did ask this, was how are we going about this evaluation? That's a fundamental, that's a research decision. And after some thought, that was when we decided to do evaluation. The way we were going to utilize reasoning at sort of a drop in the tranny, but we hadn't committed so far, paced ourselves. So, and because we were, I think, sufficiently light in how we implemented things, able to make that change, continue on. But if we, that's what I'm concerned about is software development, which doesn't constrain you.
But this
Yeah.
very case. From all these
Yes.
Yeah.
change.
That's what I'm hearing. I mean,
Right, that's right, the high level modeling. So,
that's what the domain
Well,
model
he's
is.
saying that that's actually.
okay, that's the answer to my
But the
question.
high level model didn't change. The representation and what you did with it changed. That's exactly the problem that the domain model is intended to solve. Is the
Okay.
idea is the domain models change quite slowly compared to tools underneath. Right?
Okay,
So if you can put things in, this sort of form, right? This is really high level. I mean, yeah, there are a couple of things like priority and things that are a little bit lower level. Right? But in terms of frequency ranges, I mean, those are domain concepts. They're not about reasoning.
so I buy that. No, yeah, I buy that because.
The only.
I didn't pay anything for it.
The only thing.
I'll take two.
The only place where I disagree with you is that I don't think we think of it semantic web that these domain models include semantics. They encode semantics relative to the user, and it's
Yeah.
basically the matching of this and some other code and interpretation.
Yeah, I guess when I say semantics, I mean they're capturing enough information to reproduce together all the references.
Right, as long as you have the change.
So there's some sort of like mapping there,
Right.
but they have all the information. Well, I teach that. These are typically, these domain services here are typically implemented as microservices. And the application services are essentially just a REST API or GraphQL API or whatever on top of microservice. So the microservice ends up being that thing, right? So this is like a policy, you have like command query separation or whatever, a policy reading microservice, right? And then you have some REST API which does GET, it handles all the serialization.
I had a question. Once actually founded very simple. Talking about that. But I also wanted to. Like it wasn't like really coupled as how Microsoft. I just wanted to know.
I mean, microservices are, you're talking about coupling in sort of space and time, right? So, are you talking about the actual deployment of microservices? Or?
Yeah.
Oh, okay.
It's not independent.
Oh, yeah. Okay. So, yeah, you can implement this as a big process, right? But there's nothing saying that those domain services can't be distributed. So, I mean, that's the whole idea of having the interface the dependency inversion is so that you have a high level interface and you don't care whether it's in my process. The application services are typically the API, so it's like the HTTP service more or less, and the domain service is this thing. So it's a programming language level interface.
It's not a service.
Questions?
Utilize that.
Yeah.
That sort of stuff.
No. These are typically at a library level.
Way back.
I don't know, kind of going back to the whole issue. Well, so culturally in the space, we sort of, the traditional way to learn code is very level, very much hacking. And that's kind of the household artisan practice. You think that has us thinking too much about don't think systematically about that.
Well, so there's this sort of you have this store that's open to anything more or less, and you're not getting schema. All of these other things that's kind of what I think of as when I say help students with modern software engineering. Modern software engineering is like sort of commitment, right? It's kind of in many ways philosophically opposed to the AAA thing of. So the question is where on that, at what point do you make a commitment to a set of abstractions? And you're saying, well, I want to delay that point. Definitely. The triples around, and you get what you want out of it, and I get what I want out of it. And I'm saying, actually, you can optimize the productivity and make it easy for students if you can get earlier pipeline. But there is still a place for, there's nothing saying you can't have whatever in your triple store. We're just pulling out these particular domain models. So I never said that the domain models are the only writers to the triple store or that a schema is being enforced. So at least in principle, you could have this jumble of stuff and just pull out specific stuff. Or have multiple overlapping.
Kind of realizes like if you a bit of prod mix and a bit of double core, have these domain models, then they can hack.
Yeah, exactly. And I've actually built a framework for a personal project. I piloted this architecture for a personal project over the break. The idea was that there would be this ETL thing that just worked like you were talking about, where it just shoves a bunch of triples in. And the domain model is like, hey, what's there? And maybe it's W4, and maybe it's something more specific, and will actually be less prescriptive about what we serialize, sort of Postel's law of you know what you accept, right? So this idea of like I have a big RDF store with just jumble of things from different data sources, and then the models get what they can. I want to make sure. Oh yeah, of course. I'm sure they do. If they do, I don't know about it. Typically, I've seen people re-implement this architecture because the architecture is not. Part of the whole impetus behind the architecture is that it's not a framework. It's a way of structuring some code, but it's not. There's no like domain service interface that everyone's implementing. supposed to be technology agnostic to a large degree. And that's part of the point of it, is that you isolate the technology dependencies at the edges of the system. So to have a framework, by definition, then would need to have technologies at the core of your system. So there probably are frameworks that implement the Onion architecture, but it's kind of contrary to the spirit. You should do it in a way that is comfortable to you and makes sense in your business environment. The abstractions are simple enough. The notion of domain models is just a class. So there's no fancy machinery there. You can get the serialization for free for some other, like the scale of case classes can, with a little bit of glue here and there, can serialize an isolated JSON, for example. So it's in many ways easier to pull in things rather than having a more prescriptive framework.
Any plans to generate?
Yes. So that was actually supposed to be part of. So Owen is working on the DSA DSL, and that was the idea, was to eventually take an OWL ontology and generate the model. I'm not wholly convinced that defining the DSL and that is the best way to define the DSL, or that you're going to get a lot of off-the-shelf stuff that's ready to be converted. And writing that is hard. So,
Also checks.
yeah, I'm not convinced that there's. Yeah, I'm not convinced that there's a body of things that are ready to be converted to DSL.
Well, we can write them. I mean,
yeah, I'm just saying that the work to do that may be equivalent to the work to partial generators or.
Is that because we have a limit set of use cases? Are a lot of examples that.
Yeah, I don't see other people doing that.
So many policy graphs, guidelines graphs. There aren't many other examples that work that
sent me
same
a
way.
paper on someone implemented a configuration system that actually used the OWL, underlying OWL, as the whether these two pieces fit together or whatever. So it had some sort of reasoning support in the DSL to these kinds of DSL constructs. Which I think is probably.
yeah. Although actually DSA helps.
Mostly Owen's thing. He disappeared for 2 months to do functional stuff so that he could take those restrictions. We kind of abstract that away.
So, just kind of back to that. Isn't there a role for expressing ontologies?
Or expressing ontologies, or ontologies expressing DSL.
Well, you're essentially doing.
Yeah, that's what we're.
Yeah.
Yeah, that's right. Yeah, I meant expressing ontologies. I think that would be of value because we're always searching for.
That was the original impetus behind the DSL. Why I originally suggested it, because this ontology translating into a nice OWL and useful OWL is part of writing a DSL that was very good understand.
Well, I'm thinking beyond OWL that's for expressing different. When we have the specific case of policy access. That's one kind of thing. Imagine rules-oriented expressing. What I'm thinking of is some of these other places where you're searching for ways that relation from their perspective, whether it's
spaces, but not intelligence. Those sorts of, which I'm not saying those aren't rules or anything. But DSL would seem to potentially bridge a gap.
Like the no.
Oh, yeah.
Basic scientific assertions about the world that we're in a DSL.
That's
Say this, yeah.
I'm not convinced that that couldn't be handled by parsing.
Oh, it can definitely be handled by parsing. I'm not convinced that having the extra layer of indirection of having another what is equivalent to another DSL in HAL generate a DSL parser then parse the DSL back.
More that like problem, for example, where if you can generate a domain model for problem from the problem topology directly, then you prof store that.
Yeah. Yeah. Okay. Yeah.
Any other questions? Yeah, keep on it.
Yeah. Yeah. I'm a little bit into flower arranging. My mother is a advanced Ivana practitioner, so something very interests me. What? Yeah. Yeah. Yes.
Actually, this is
He does that well with his presentations.
no. I think it's excellent. Students should learn from this, even when all you're showing are bullets. Have something interesting on your slide.
That's why I have a different kind. Actually, when I did my owl talk, I put in.
Yes, you did.
Owls.
Yeah, it was good.
That's inspired.
So don't try. Are you trying to figure out relevance?
Actually, with the owl thing, like, that was owl.
Is that a particular?
Oh no, I was pulling off the.
What's the relationship of Kibana? Is that Ecobot?
Yeah.
I was thinking Kibana, which is the
Yeah,
interface.
figure out.
Anyways, let's thank